Chapter 3. Linear equations in two variables. So first we'll see what is the standard form of linear equation in two variables. It is ax plus by plus c is equal to 0 where a is not equal to 0 and b is not equal to 0. So what will happen if a is 0 and b is 0? If a is 0, then the equation will become by plus c is equal to 0, but it won't be the equation in two variables. Similarly, if b is equal to 0, it will be ax plus c is equal to 0, which will have only one variable. Now, what will happen if c is equal to 0? If c is equal to 0, the equation will reduce to ax plus by is equal to 0, which will remain linear equation in two variables. Now about the simultaneous equations. When we consider the system of two linear equations in two variables, such equations are called simultaneous equations. When the simultaneous equations are satisfied by the same pair of values of the two variables, then such pair is called the solution of the given simultaneous equation. Now the first method to solve such equations is by graphical method. So the question, solve the given simultaneous equation using graphical method. The equations are 4x is equal to y minus 5 and y is equal to 2x plus 1. So the first equation is, to draw the graphs of the two given equations, we find two solutions of each equation and make the tables like this. So the first is 4x plus 5 is equal to y. That means when x is equal to 1, y is equal to 4 into 1 plus 5, that is equal to 9. When x is equal to minus 1, y is equal to 4 into minus 1 plus 5, that is plus 1. And when x is equal to minus 2, y is equal to 4 into minus 2 plus 5, that is equal to minus 3. So the points are 1, 9, minus 1, 1, and minus 2, minus 3. For the second equation, y is equal to 2x plus 1. So when x is equal to 1, y is equal to 3. When x is equal to 2, y is equal to 5. When x is equal to minus 3, y is equal to minus 5. So the points are 1, 3, 2, 5, minus 3, minus 5. So this is the graph paper. This is x-axis. This is y-axis. This is the origin O. Now we'll plot the points for the first equation. 1, 9, minus 1, 1, minus 2, minus 3. And now we'll draw a line passing through them. Now we'll plot the points of the second equation. 1, 3, 2, 5, minus 3, minus 5. Now this is the line passing through them. And the point of intersection is the solution of the given simultaneous equations. They are minus 2, minus 3. Now another method is determinant method. If a, b, c, d are any four numbers, the value ad minus bc is represented as. This type of representation of numbers is called as determinant of order 2, as it has 2 rows and 2 columns. So the first equation is a1x plus b1y is equal to C1 and the second equation A2x plus B2y is equal to C2. So, D is equal to A1B1, A2B2. Dx is equal to C1B1, C2B2. And dy is equal to A1C1, A2C2. Now, x is equal to dx upon d and y is equal to dy upon d. This method is known as Cramer's rule. Now solve the equation using Cramer's rule. 3x plus 2y plus 11 is equal to 0 and 7x minus 4y is equal to 9. Now, the first equation 3x plus 2y is equal to minus 11 and the second equation 7x minus 4y is equal to 9. Therefore, D is equal to 3, 2, 7 minus 4, that is equal to minus 12 minus 14, that is equal to minus 26. And dx is equal to minus 11, 2, 9 minus 4, that is equal to 44 minus 18, that is equal to 26. Now dy is equal to 3 minus 11, 7, 9, that is equal to 27 plus 77, that is equal to 104. Therefore, x is equal to dx upon d, that is equal to 26 upon minus 26, that is equal to minus 1. And y is equal to dy upon d, that is equal to 104 upon minus 26, that is equal to minus 4. Now we'll see about the condition of consistency of equations. The simultaneous equations are said to be consistent if they have solution, and the simultaneous equations are said to be inconsistent if they do not have solution. In case of simultaneous equations, when we do the comparison of ratios, if a1 upon a2 is not equal to b1 upon b2, then it is having a unique solution and the equations are consistent. When a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2, there is no solution and the equations are inconsistent. That means, when the equations are consistent, there are intersecting lines, and when they are inconsistent, the lines are parallel. Now, if a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, then the equations are consistent and they are having infinitely many solutions. In this case, the graphical interpretation is of coincident lines. So now, without solving the simultaneous equations, decide whether they have unique solution, no solution, or infinitely many solutions. The equations are 3x plus 5y is equal to 16 and 4x minus y is equal to 6. Here, a1 upon a2 is equal to 3 upon 4 and b1 upon b2 is equal to 5 upon minus 1, that is equal to minus 5. And therefore, a1 upon a2 is not equal to b1 upon b2, and therefore these are the intersecting lines with unique solution. Then next equations, 3y is equal to 2 minus x and 3x is equal to 6 minus 9y. So the equations are rearranged as x plus 3y is equal to 2 and 3x plus 9y is equal to 6. Here a1 upon a2 is equal to 1 upon 3, b1 upon b2 is equal to 3 upon 9 is equal to 1 upon 3, and c1 upon c2 is equal to 2 upon 6 is equal to 1 upon 3. That means a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So there are infinitely many solutions. Next one. 3x minus 7y is equal to 15. 6x is equal to 14y plus 10. So the equations are rearranged as 3x minus 7y is equal to 15 and 6x minus 14y is equal to 10. Now a1 upon a2 is equal to 3 upon 6 is equal to 1 upon 2. b1 upon b2 is equal to minus 7 upon minus 14, that is equal to 1 upon 2. And c1 upon c2 is equal to 15 upon 10, that is equal to 3 upon 2. That means a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2, and therefore the equations have no solution. Now next question. Solve the following simultaneous equations. 27 upon x minus 2 plus 31 upon y plus 3 is equal to 85, and 31 upon x minus 2 plus 27 upon y plus 3 is equal to 89. Let 1 upon x minus 2 is equal to a and 1 upon y plus 3 is equal to b. Therefore, 27a plus 31b is equal to 85, equation 3, and 31a plus 27b is equal to 89, equation 4. By adding equation 4 and 3, we get 58a plus 58b is equal to 174. That means a plus b is equal to 3, equation 5. Now we'll subtract equation 4 from equation 3. Therefore, 31 minus 27 is 4a and 27b minus 31b is minus 4b. That is equal to 4. So a minus b is equal to 1, equation 6. Now we'll add equation 5 and 6. So a plus b is equal to 3 and a minus b is equal to 1. That means 2a is equal to 4. Therefore a is equal to 2. Substitute the value in equation 6. So a minus b is equal to 1. Therefore 2 minus b is equal to 1. Therefore minus b is equal to 1 minus 2. Therefore minus b is equal to minus 1. Therefore b is equal to 1. But a is equal to 1 upon x minus 2. Therefore 2 is equal to 1 upon x minus 2. Therefore 2x minus 4 is equal to 1. Therefore 2x is equal to 5. Therefore x is equal to 5 upon 2. Similarly, b is equal to 1 upon y plus 3. Therefore 1 is equal to 1 upon y plus 3. Therefore y plus 3 is equal to 1. Therefore y is equal to minus 2. And therefore the solution is x is equal to 5 upon 2 and y is equal to minus 2. Now a word problem. A house has rectangular yard in front of it for children to play. The length of that rectangle exceeds its width by 6 meter and its perimeter is 60 meter. Find the measurement of the yard. Let the width of the yard be x meter and therefore the length is x plus 6 meter. So perimeter is equal to 2 into bracket L plus B, that is equal to 2 into bracket x plus 6 plus x, that is equal to 2 into bracket 2x plus 6. But the perimeter is 60 meters and therefore 2 into bracket 2x plus 6 is equal to 60. Therefore, 2x plus 6 is equal to 30. Therefore, 2x is equal to 30 minus 6. Therefore, 2x is equal to 24. Therefore, x is equal to 12. And therefore, width is equal to 12 meters and length is equal to 12 plus 6, that is equal to 18 meters.